Hi, everyone. I'm with Raiden. You want to say hi?
Hello.
Hello. We're going to talk about division today. Oops, I need a color. Division. Okay, so there's lots of things we can talk about division. You were saying this word earlier, quotient. And what did we say that quotient means? Do you remember?
The number you get from dividing the
Yeah, dividing. That's exactly right. The number you get when you're dividing. So it's like we said something like 35 divided by 5 equals
7.
7. Good. And what does 35 divided by 7 equal?
5.
5. And this is because the product of 5 and 7 is
35.
35. And product means the answer
of a multiplication equation.
Yes, to multiplication. Perfect. So multiplication and division are like what we call, they actually have a special name. They're called inverse operations. And that's just because they're opposites of each other, right? So when I have a division problem, it's the opposite of a multiplication problem. And notice this little division symbol. Does it look like anything to you? That little symbol that means divide?
No.
It kind of looks like, to me, it looks like a fraction.
Oh, yeah.
It does, yeah. So a division is actually like a fraction. So if I write it as 35 over 5, that actually means the same thing. That means divide. So the division symbol is a little tiny fraction. We can also write it as 35 over 7 equals 5. And that means the same thing. Have you ever seen it written like that with the fraction bar division?
Yeah.
Yeah.
Bit.
And then we can there's another video that I'm going to have you watch. It's called Divisibility Rules. Divisibility Rules. So those are just like, does something divide evenly into another? So if we have the number 2, all even numbers are divisible by 2. So let's think about that for a minute. So can you give me an example of an even number? Any even number. Think of a big one. How do you know it's even?
100.
Yeah, 100 is even. What about it says that it's even? Do you know?
The number is I don't know.
Yeah, it's hard to describe. The last digit has to either be a 0, 2, 4, 6, or 8. Those are all evens. The last digit has to be. So if I said 101, is 101 even?
No.
No, it's not.
It's odd.
Even. Okay, so what if I took 100 and I divided it by 2? That's essentially half. What's half of 100?
50.
50. But if I tried to take half of 101, it wouldn't go in evenly. I would have some remainders, right? And that's okay. I can have remainders. So do you happen to know the divisibility rule for 3? How do I know if a number is divisible by 3? Well, let's think about multiples of 3. What are the multiples of 3? Multiples of 3, by the way, are like when you count by 3. So go ahead and say all of the numbers, just start counting by 3, starting with 3. 3.
6. 9.
Yes.
12.
Yes.
15. 18.
Good.
21. 24.
And do these ever stop?
No.
They would go on for infinity. So there's an infinite amount of multiples. And when you hear this word multiples, right, you can think of multiplying. When you have the multiples of 3, you're multiplying by 3. Now, these go from odd. 3 is odd. 6 is even. 9 is odd. 12 is even. 15 is odd, 18 is even. So they alternate, you know, and so we want to know, how can I come up with a rule so that I know if I have a really big number and I wanted to do division, would 3 go into it? Well, it turns out that 3 has this really special feature, the multiples of 3. If you add the digits, so what's 1 plus 2?
3.
And what's 1 plus 5?
8. No, 6.
6. What's 1 plus 8?
9.
Yes. Do you see, are you starting to see that pattern? So 3, 6, 9. If you add the digits, okay, add the digits 2 plus 1. What do you get?
3.
2 plus 4.
6.
6. Yes. And I bet you anything after 24, it goes 24, 27. 2 plus 7 is 9. Isn't that amazing? So all of the digits, all of the multiples of 3, the sum of the digits add to 3, 6, 9. They add to multiples of 3. So if I came up with a really big number, let's say I came up with the number 1, 2, 3, 4, 5, 6. Let's add those digits. So 1 plus 2 is
3.
and 3 plus 3 is
6.
so 1 plus 2 plus 3. So far we're at 6. And then 4 plus 5 is
9.
good. And then if we add the 6, so we're going to add 6 plus 6 and we get
12.
And 12 plus 9 gives us, because I'm taking this 9, the 6 and the 6 and the 9. So what's 12 plus 9?
12 plus 9 is 21.
21. 21 is a multiple of 3. Okay, so I only did a little bit of the divisibility rules. There are more, but I don't want to spend this video doing that. I wanted to get to long division. So let's say we know, because this is 21 and 21, 2 plus 1 is 3. 3 is going to divide into this number evenly. So we're going to do long division. Okay, I'm going to get a different color. So for long division, we're going to take 1, 2, 3, 4, 5, 6, and we're going to divide it by 3. And remember that fraction bar is a division problem.
Yep.
The way we set up long division is we put the 3 out front and we're going to divide it into 1, 2, 3, 4, 5, 6. And actually that's 123,456. That's how we read the number with place value, right? So 1, 2, 3, 4, 5, 6 divided by 3. These are all different ways you can write this division problem. So there's this way means divide, there's this way means divide, and then there's this is how we set it up for long division. So the way we're going to do long division is we're going to start with going, how many times does 3 go into 1? Well, I can't divide 3 into 1, right?
Yeah.
So I go, how many times does 3 go into 12, the first 2 digits? How many times does 3 go into 12?
4.
4, exactly. So I put the 4 above the 2, and then I go 4 times 3 is 12. So I'm going to put the 12 down here, and I'm going to subtract them. But I don't have anything left, right? So I have 0. Now I'm going to bring down the 3. How many times does 3 go into 3?
1.
Good. So I put the 1 up top right above the 3, and I have 3 times 1 is 3. Subtract those, I have 0. I'm going to bring down the 4. How many times does 3 go into 4?
1.
1. So we put a 1 above the 4. 1 times 3 is 4. We bring the 4 down. 1 time, or so not, it's not 4. It's 3. Undo. 3. Okay, we subtract. Now, what's 4 minus 3?
1.
So we're going to bring that 1 here. That's our remainder. We're going to bring the 5 down. How many times does 3 go into 15? You see how that became 15? Okay, how
Yeah.
many times does 3 go into 15?
5.
5. So we put the 5 up top. We have 15. We subtract. We have 0. And then we're going to do what with the 6?
Put it down.
How many times does 3 go into 6?
2.
2. We put the 2 up top. 3 times 2, 2 times 3, whatever, is 6. We subtract. We have 0 remainder. So that means that the quotient of 123,456 and 3 is 41,152. If you wanted to check that,
you multiply 3 times 41,152.
yes, you would. 3 times 41,152. And if you do that multiplication, oops, now my thing went weird. We should get, if you do that multiplication, you should get 123,456 if you multiply that out. Do we want to go over how to multiply it, or you know how to do that already? You could also check it maybe on a calculator. I'm thinking you might have froze. You're frozen. No, 1 second. Oh, are you there? Recording. Okay, so that was awesome. You just checked to see that this worked out. You did multiplication. We're not going to go over multiplication now. It's another video. Okay, so now we wanted to do a different problem, a 2-digit. So I just made up the number 14,456 divided by 12. I actually don't have a divisibility rule for 12, but there is one on another video I made for 6, 5, or 5, 6, 9, and 11, and 10. Okay. So we're gonna divide here by 12. So for setting up long division, remember that this is the same as 14,436 divided by 12. That also means divide, that fraction bar. Okay, so this means divided by. And then we're going to set up long division. So we have 12 into 14,436. That was a really dramatic line. I don't know why I needed to make it that long. Okay, so now we're going to start with 12 into, we know 12 is not going to go into 1. So we're going to skip over the 1 and go, how many times does 12 go into 14? Those first 2 digits. How many times? What did you say?
1.
1 time. Good. And so now we have 1 times 12 is 12. We put the 12 down there and we're going to subtract. So now 14 minus 12 is 2, right? Is that right?
Yeah.
And I'm going to bring down the 4. Now, how many times does 12 go into 24?
12?
Mm-hmm.
Go into 24. 2.
2, exactly. So we're going to put the 2 above that 4 that we just brought down. And now we have 2 times 12 is 24. There's no remainder. So that's 0. And then we bring down the 3. How many times does 12 go into 3?
0.
0. So what should we do if it goes in 0 times? Do we need to put anything down or do we just skip it?
Skip it.
Well, we actually need to put a 0 here because I'll show you why in just a minute. Okay, we are going to want to put a 0 here as a placeholder because let's say, Raiden, you had a bank account. Okay, is it going to be different if you have this much money in the bank account or this much money? Which one would you want? $12 or 120?
120.
Yeah, so these are not equal. So we do want that 0 in there. So we're going to put that 0 there. A lot of people will forget that. That's why it's a little bit harder. Now we're going to bring down the 6. How many times does 12 go into 36?
3.
Exactly. And then 3 times 12 is 36. So here we have no remainder. Now there's a whole other video that we can make about remainders and how to deal with remainders. And now I'm having a hard time spelling remainder, but so we could keep going and do division with remainders, and then you can get into decimals and fractions with that, because decimals and fractions are technically how we deal with remainders. Have you guys been doing remainders?
No.
No. So everything right now, this is called this is dividing evenly. So right here, we could say the quotient. How would you put it into a sentence? The quotient of
12 divided by 14,436 is 1,203.
Yes, 203. Good. And so if I didn't put that 0 in, is this the same number 1, 2, 3 if I left the 0 out?
No.
So that wouldn't be the correct answer. And you could always check that. If you were to multiply, if you were to find the product, right? If
I'm
you
doing
left,
that right now.
yeah, the product of 112 and 123 is not going to be the same thing as the product of 12 and 1,203. So a lot of times people will forget that 0. So I'm really glad that actually came up. That was a good thing to go over. So if you check this, you want to check to find out if your answer is right. What's that?
I got it correct.
Good, good. And I love that you're checking. Okay, is there any other kind of division problem that you want to do, like a word problem or maybe 3 digits? What else do we need to go over when it comes to division? I have an idea. How about estimation? Have you heard of this, estimation?
Yeah, you estimate, and then whatever that number is, you're gonna be close to it.
Yeah. So if I had like a really big number, let's say I had 6,543,798, and I wanted to divide that by 297. Oh my gosh, those numbers are so big. I could estimate. In fact, actually, I don't want to make that 5. I want to make that 2. Okay, so when we estimate, if I'm going to estimate, I can round the numbers first. So if I look at this number, I'm going to say, well, that number is really close to 6 million. So I could say 6 million divided by, what would you round that number to? 297. Is it closer to 200 or closer to 300?
300.
So we could round it to 300. And then we're like just dividing 300 into 6 million.
Yep.
But even check this out. This is even going to be an easier problem. If I have 6 million divided by 300, oops, that was 3,000, my bad.
2.
It's really going to be the same problem as, get rid of 2 zeros on the top, 2 zeros on the bottom, 60,000. Oops, I put the comma in the wrong place. Because I have 4 zeros now, 60,000 divided by 3. So how many times does 3 go into 6?
2.
Yeah, so this is going to be, and then 3 goes into 0, 0 times, 3 goes into 0, 0 times, 3 goes into 0, 0 times. So 20,000. Now, do you have a calculator handy?
Yeah.
So take on your calculator, plug in that number, and then push divide and plug in that number, and we're going to see what we get on the calculator.
6,000. No, 60,000.
It's actually 6,243,798. And then divide that by 297.
Okay.
And what'd you get when you pushed enter?
Yep. Almost there.
Okay.
300. No.
300?
Oh, 297.
297, yes.
Not
Yes,
bad.
that was 21,022, right? So check that out. When we estimated, we got really close at 20,000. You see how estimation works? It just kind of gives you an easier group of numbers to work with. So anyway, that's estimation. And then especially if you're dealing with really big numbers and you have to do division, it can just be an easier problem to solve using estimation. All right, well, I'm happy to do other problems next time. So let's go ahead and leave it at that. And then if we have any more requests for our YouTube channel, we can always do more videos, or if you can come up with other problems that you want to try and solve. Okay.
Yeah.
Thank you for joining me.
Yeah.